So let us start the electrochemistry questions from the year 2025 onwards. Here you are asked to, the question is, according to the moving boundary method, the transport number of Ta plus, the positive ion, of the principal electrolyte is calculated using the formula. You are asked to determine the formula of the moving boundary method. As you know, the transport number, for the determination of transport number, we have got two important methods. Which are the two important methods? One is uh, Hitto's method. One is Hitto's method, and the second one is moving boundary method. Moving boundary method. So in the moving boundary method, this is a schematic diagram of that experiment. This is the coulometer in which you can determine the total charge Q, and here is our apparatus. So basically what is happening is that when you apply DC current here, this boundary, so there will be two electrolyte solutions, like if you are taking HCl, the other one may be cadmium chloride. It should have both same anions, so you can determine the positive one, the transport number of positive ion. So if that is the case, and if you mix this solution, and there will be a small boundary here, and this boundary will be moving to here. So this is, if this is the negative electrode, the positive ions will be moving here. So this is the volume. This is a cylinder. So if this length is L and the cross sectional area is A, so the volume will be equal to L into A. So a volume of this much solution has been passed here. So if a volume has been passed, means how many number of ions are there, all those ions will have been carried from here to here. So now let us see the equation for transport number of positive ion is charge carried by positive ion divided by total charge. So as I mentioned earlier, total charge you can get it from the Q, from the coulometer. So this can be given as charge carried by positive ion divided by Q. Now we have to determine the charge carried by positive ion. So charge of positive ions, the total number of positive ions will be equal to equivalence of ions. How many equivalents of ions are there, multiplied by the Faraday. So now what will be the equivalence of ions? Equivalence of ions will be equal to volume of that particular ions, volume of that solution multiplied by the concentration. So volume of ions, as I mentioned earlier, it will be L into A multiplied by C. So charge on positive ions, charge of positive ions will be equal to L into A into C into F. Now if you check the T plus, it will be equal to what? It will be L A C into F divided by Q. So this will be the transport number of positive ion by moving boundary method. Now once you check the options, you can see, you see here LAC by Q by F. So this will be equal to L into A into C into F divided by Q. Mean that option and our equation is exactly the same. So your right option will be this one. It's a very important question. Students are reminded to go through the Hitto's method also. Thank you.